Lab 5, Choose Your Own Adventure, Morgan Jackson, Dr. Greco, Section MO2. For my adventure, I chose to examine different free throw techniques of some of the best women's basketball players in the world, both key parts of the USA women's team in the 2012 Olympics, these two being Diana Taurasi, number 12, and Tina Charles, number 14. By examining their shots, we were able to figure out the physical components involved in shooting an optimal and accurate free throw shot. Let's first look at some of the goals of this experiment. These are to find initial velocities using Tracker, to compare initial velocities found in Tracker to the values calculated, to make a model using VPython of each shot, and to calculate the net force on the ball for each player. Here are some of the results from the experiment. By calculating the initial velocities of each player, I calculated the initial velocity of Diana Taurasi to be 5.923 meters per second in the y direction and 5.3859 meters per second in the y direction for Tina Charles. The force exerted on the ball by each player was 5.923 newtons by Diana Taurasi and 6.097 newtons by Tina Charles. And finally, even though the ball left Taurasi's hand with a higher velocity, Tina Charles exerted more force on the ball. We will look at these calculations in their meetings throughout the video. To begin this analysis, we need to analyze the videos in Tracker. Let's start out with Diana Taurasi. We can track the position of the ball in Tracker and generate a position versus time graph for the x and y positions, as well as graphs for the change in velocity in the x and y directions. However, it is important to note the imperfections in this video as a potential source of error. The poor video quality limits the tracking ability of this program, but it's good enough for us to make some important conclusions. These will be analyzed later. By looking at the graphs that Tracker predicts from analysis, we can see the initial velocity of the ball as soon as it leaves her hand. These are both graphs of the velocity versus time in the x direction and the y direction. This value is shown at the bottom. Using the energy principle, we can calculate what we should find to be the initial velocity in the y direction. If we compare this to what Tracker found in the y direction, these values seem fairly close. Using the data found in Tracker and some observations from raw videos, we can create a model in Python for the position of the ball as it travels. After inputting the initial conditions like velocity and position found from Tracker, this is the main while loop written for this model. For FNet, we need to account for the drag force and force due to gravity. This is shown circled in blue. Then we can update position and velocity of the ball toward the end of the loop. This is shown circled in red. These are the most important lines of code and help us track the position and velocity of the ball as it travels. Here's the model that results. This model is very similar. This model is particular for Diana Taurasi, and it is not a perfect representation, but it gives us a good idea of how the object is traveling. Next, we need to compare it to Tina Charles' Tracker data. The same analysis can be done by examining position versus time in both the x and y directions, as well as velocities like we did previously for Diana Taurasi. Similar to what we did previously, we can look at what velocities Tracker predicts for Tina Charles. These are shown at the bottom. We can again use the energy principle to again calculate the correct value for the initial velocity at which the ball was thrown. Again, this is fairly close. From here, we can make a model in Python showing the trajectory and path of her shot. The procedure was identical to what we did previously for Diana Taurasi, however, initial conditions were changed based on the data for Tina Charles gained from Tracker. Now, let's look at the meaning behind these numbers a little closer. We know that both shots went in the basket, so their initial velocity should be the same, right? Well, there are factors that we haven't considered, like the angle of trajectory which the basketballs were launched. The graphs of the x and y positions versus time are shown at the bottom from Tracker. Even though Tina Charles' graph has a slightly larger slope from the data from the first position, she is 4 inches taller than Diana Taurasi. Therefore, in order to reach the basket, Taurasi needs to release the ball at a faster speed in order to overcome the height at which she's lacking in comparison to Charles. For our last calculation, let's calculate the net force on the ball at the moment that each woman released it. This calculation ties together the other ideas that we've been working with previously. Here we can use VFinal as the moment which the ball is at the top of the arch of the path of trajectory. Here VFinal is 0. From looking at this calculation, we can see that Tina Charles exerts more force on the ball than Diana Taurasi. Even though Tina Charles is taller, the angle at which she shoots is steeper, causing her to have to exert more force on the ball. In conclusion, it is important to note that there are many possible combinations for the perfect free throw. This is shown extremely well in this situation. For your specific height, there is a perfect combination of the force applied to the ball, the angle at which you release the ball, and other kinesthetic aspects of the motion of your body as you shoot. This takes extreme practice, however, basic physics principles can be applied here to discover what those numbers look like for you specifically. Best of luck finding that. Here are some web sources for the pictures I used in this presentation. Thanks for watching.